Okay, problem number 2. This one's way more difficult. Problem 2, give myself a little bit of space. Step 1 is to factor the numerator and the denominator. So here we go. I'm going to factor the numerator, and I'm going to pull a 3x out of each one of those terms, and I get x minus 1 when I factor the numerator. In the denominator, whenever I'm trying to factor a polynomial, I put down a couple factors. I put an x here, I put an x there. I want the factors of 12 that are going to add together, or I should say factors of negative 12 that are going to add together, give me positive 1. Well, if I had negative 3 times positive 4, that's going to give me a positive 1 right in there. So if I put plus 4 here, let's say, and a minus 1 over here, that's going to give me the correct middle term. Whoa, wait a minute, hold on, I put the wrong number there. 3, I put a 3 here, that's going to give me negative 12 at the end, and it's going to give me a positive 1 right in the middle term. Now, there are no common factors on these guys, so on this particular problem here that I have, there is no whole that I'm going to be able to, cancel out. All right. So what do we do from there? We're going to put down our vertical asymptotes. Our x equals negative 4, x equals positive 3. Those are the zeros in the denominator. Negative 4 and positive 3, right? There is none. And the horizontal asymptote, because the degree in the numerator is the same as the degree in the denominator, we take the leading coefficients, like 3 over 1, and we get y equals 3. That's probably the best way to write it, y equals 3. X-intercepts are when the y is equal to 0, right? So the only way we're going to make the y 0 is if the numerator equals 0. So that would be when x is 0 and when x is 1. So I get 0, 0, and 1, 0. Okay, that's what's going to make the y value 0. In the x or the y-intercept, that's when we let x equal 0. So if I replace all of these with zeros, I get 0, 0. So you can see the x and y-intercept are the same. Let's put those dots on our picture here. Okay, and let's put down the vertical asymptotes. That was at negative 4 and at positive 3. Okay. Noticing also that the factors in the denominators have an exponent of 1, which means that it's going to be going in opposite directions around these asymptotes, right? So it's either going to be going down and then up over here, or vice versa, right? So I need to figure out what is it doing on one of the sides. Oh, and we also probably need to put the horizontal asymptote on there too, right? So if I go 1, 2, 3 up, here's my horizontal asymptote. Okay, at y equals 3, and I'd like you to label this stuff on your graph. Okay. Now let's see. Got all the asymptotes on there. Let's try and find which direction it's going, like down or going up. So how about I try negative 4.1 at x equals negative 4.1. If I put negative 4.1 into all of this information, I'd have 3 times negative 4.1 times negative 4.1 minus 1 all over negative 4.1 plus 4 times negative 4.1 minus 3. That equals, so I'm plugging in negative 4.1, and for wherever I see x, I end up with negative 12.3 times negative 5 something, so that's going to be like positive 60-ish. I'm going to put 60-ish up in the numerator. All over here I've got negative 0.1, right? Negative 4.1 times, or plus 4 is negative 0.1. And then we got negative 7.1 right here. Hey, look at this. This is a positive number That's 0.7. So we got 0.7 divided into 60-ish. So 60 divided by like 0.7 is going to be kind of a large positive number. So on this side of my vertical asymptote, I know the function is getting closer to the vertical asymptote. It's going to positive infinity. It's going to come down and get close to the horizontal asymptote. And then since this one's going up, I'm going to make this one go down. Now it's going to come up here. It's got to cross over this x-intercept, and it's got to cross over this x-intercept. How do I know that? Because the powers on the x-intercepts are 1s. So I'm going to make it cross up and through, and then back down. Now if it's going back down through, it's got to go down on this side. And then that means it switches and it goes up on this side. And it's going to come down from that asymptote over there and get closer to the horizontal asymptote. All right? So this is what I'm looking for on your rational function. Just a sketch, a rough sketch, showing the behavior near the asymptotes. Okay? See, we were saying, like, by studying negative 4.1 that the limit of the function r of x as x approaches negative 4.1 from the left side, so you put a little minus to say from the left side, it's going to positive infinity, right? So from the left side, over here on the left side of the asymptote, we found that it went to positive infinity because of our little calculation right over here, 60 divided by 0.7, which means it's going to be a big positive number, right? And then the rest, we didn't keep studying this. We just said since it's going up on the left, it's got to be going down on the right. And because we knew it came through here and went back down there, it's got to be getting close to the asymptote over here, going down to negative infinity. So this one switches and goes to positive infinity. Hope I'm making that clear. Thanks, everybody.